Good morning, ma'am. Myself Sandhya and I'm from the CSMC. My topic is about clustering unsupervised learning techniques. Coming to the introduction of a clustering. Clustering is a fundamental technique in unsupervised machine learning. It involves grouping similar data points together based on a certain characteristic. This technique is widely used in a various fields such as marketing and biology. And I want to explain about what is an unsupervised learning. Coming to the unsupervised learning is a type of machine learning where no labeled data is used. The model learns pattern and structure from the data itself. Clustering is one of the primary method of unsupervised learning. Unsupervised learning versus supervised learning. First of all, properties. Unsupervised learning. Unsupervised learning as a type of machine learning that happens without human supervision. A machine tries to find any patterns in a data by itself. Coming to the unsupervised learning, supervised learning is a type of machine learning that happens under a label through data with the answer key showing a mission and the desired outputs. It is an unsupervised. It is an unlabeled. In supervised, it is an labeled. A model is a given only input variables and no corresponding output data in unsupervised. In supervised, a model is given input variables, output variables, and an algorithm to learn the fundamental inputs and outputs. You don't know what you are looking for the data. You don't know what looking for on a data in supervised learning. Clustering and association problems in a classification and regression in supervised may provide less accurate results. It is provides more accurate. In unsupervised k-means Gaussian mixture models, frequent patterns, growth principal components analysis. In supervised support vector, decision tree, random forest, Navi base. And in use cases, recommended systems, anomaly detection, customer segmentation, preparing data for supervised learning. In this demand forecasting, price prediction, image recognition in the supervised. And coming to the importance of clustering helps in discovering hidden patterns in the data. It can simplify data by reducing the dimensionally. Business use clustering to segment customer for targeted marketing. Types of clustering. There are several types of clustering including pathfinding and hierarchical. Density based and model based clustering are also popular methods. Each type has its own advantages and is suitable for different scenarios. And coming to the k-means clustering. In the k-means clustering, k-means is one of the most widely used clustering algorithm. It participants data into k distinct clusters based on feature similarities. The algorithm iteratively refines cluster centers to minimize variance. In a hierarchical clustering builds a tree of clusters in a nested fashion. It can be either agglomerative bottom up and a division top down. This method is used for understanding data relationship at a different levels. Hierarchical clustering algorithm types: agglomerative and divisive. In density based clustering identifies cluster based on a data point density. Density based spatial clustering of application with noise is a popular algorithm. This method can find arbitrary shaped cluster and handle noise effectively. Model based clustering assumes the data is generated from a mixture of a probability distribution. Gaussian mixture models are commonly used for purpose. This approach allows for a soft clustering where data points can belong to multiple clusters. Evaluating clustering quality. Evaluating clustering results can be challenging due to the lack of labels. Metrics like score and Davis Boolean index are used to assignment. Visual inspection and dominant knowledge also plays crucial role in evaluation. Applications of a clustering. Clustering is applied in a customer segmentation for targeted marketing strategies. It is also used in image processing for object recognition and classification. In a biology, clustering helps in organize or specialize based on similarities. Challenging in clustering. Choosing the right number of clusters can be subjective and challenging. Clustering algorithm may be sensitive to noise and outliers in the data. High dimensional data can complicate the clustering process and lead to the codes of a dimensionality. Here is a picture really, and coming to the data processing of a clustering. Data normalization and scaling are crucial for effective clustering. Holding missing values and outliers can improve the clustering outcomes. Future selection can help in focusing of the most relevant attributes of the data preprocessing, future scaling. Tools for clustering. Popular programming language for clustering includes Python. Libraries such as sktls, TensorFlow, and Keras provide a clustering algorithm. Visualization tools and Matplotlib and Seaborn can help in interpreting results. Case study, customer segmentation. Coming to the case study, a retail company used K-means clustering to segment in a customer base. These insights gain help the company tailor marketing campaigns effectively. Clustering analysis result in a significant increase in a customer engagement. And a future trend in clustering, advance in deep learning or leading to new clustering methods. Automated clustering and interpretability or becoming focal research areas. The integration of a clustering with the big data technologies is on the rise. Clustering versus classification. Clustering is unsupervised while classification is a supervised learning techniques. In clustering, the model finals grouping. In a classification, it predicts labels. Understanding difference helps in selecting the right approach of a problem. And coming to the conclusion, clustering is a powerful tool for understanding and organizing data. Its diverse application make it valuable techniques across industries. Continuous advancement in algorithm and technologies are enhancing in capabilities applications. Anomaly detection, geographic data analysis, image segmentation, customer segmentation, network traffic analysis. Thank you, ma'am.